We are in part 2 of 6.1 and we're picking up with the compound interest. So compound interest can be calculated using the formula A of t equals P times 1 plus R over N to the N times T. A of t is the account value over time. T is measured in years. P is the initial starting value, which we also call principal or the general present value. R is the annual percentage rate expressed as a decimal, and N is the number of times that it compounds during the year. For instance, if it compounds quarterly, it would compound 4 times a year. If it compounds monthly, it would compound 12 times a year. So we're going to try this one. An initial investment of $100,000 at 12% interest compounded weekly. What will the investment be worth in 30 years? So we know the initial amount is $100,000. And we know that the interest rate is 12%. The number of times it's compounded is 52, and the number of years is 30. And all we have to do is substitute those values into the equation above to find A of t. Oops. So when t is 30 years, it will be 100,000 times 1 plus 0.12, which is the interest rate, over N, which is 52, because there are 52 weeks in a year, and if it's compounded weekly, that's 52 times, and then it's carried to the N, which we just said was 52, times T, the number of years, which is 30. And you can sub this whole thing into Desmos. So 100,000, parentheses, 1 plus 0.12 over 52, carried to the, and I'm going to put this in parentheses, 52 times 30. Woo. And that looks like 3,664,675. $664. 0.88. Okay, so let's look at this one. A 529 plan is a college savings plan that allows relatives to invest money to pay for a child's future college tuition. The account grows tax-free. Lily wants to set up a 529 account for her granddaughter and wants the account to grow to $30,000 over 18 years. She believes the account will earn 4% compounded semi-annually twice a year to the nearest dollar. How much will Lily need to invest in the account now? So we don't know the general amount. This time we know what it's going to grow to. It's going to grow to $30,000. We don't know P. That's the initial value. We want to know how much she needs to invest, and we don't know what that is. Interest rate, she believes, is 4%. The number of times it's compounded is 2, twice a year. And then the number of years would be 18. So filling in this formula, we know that $30,000 is equal to P, which we don't know, times 1 plus 0.04 over 2, carried to the 2 times 18. So for this kind of problem, we're not looking for the account balance over time. We're looking for the initial balance that we initially want to invest. We're looking for the P. So when you're doing this type of problem, you want to simplify the right-hand side first. So that's 1 plus 0.04 divided by 2 is 0.02. Carried to the 2 times 18, which is 36. So that's 30,000 P times 1.02 carried to the 36. Now, we could carry 1.02 to the 36th power, or we can just go ahead and divide this on both sides. Divide both sides by your 1.02 carried to the 36th power. And we can let our calculator do all the heavy lifting. So, 30,000 divided by 1.02 carried to the 36th power. And it looks like we get $14,706.69. Oops. 14,706.69. Okay, so now we're going to talk about functions with base e. Base e represents the rational number 1 plus 1 over n, all of that carried to the n power as n increases without bound. It's approximated by 2.718282. You do not have to memorize this. The calculator has this stored in it, whether you're using the TI-84 or Desmos. So let's calculate e to the 2.53 carried to the 5th decimal place. So e to the 2.53. You can just type the letter e, and you see that the value of e pops up. Carried to the 2.53, and they want us to round to 5 decimal places. So that looks like 12.55351. I believe I wrote that correctly, but let me just double check. 12.55351. Yep, that's it. Alright, so now you guys try e to the negative 0.5 and round to 5 decimal places. Unpause the video when you're ready to go over it. Okay, so if we went to our calculator and we did e carried to the negative 0.5, carried to the rounded to the 5th decimal place, 0.60653. I'll try it. Just look one more time. Make sure I have it right. 0.60653. That is correct. Alright, so E can be used in many different types of formulas we use for real life applications. One of them has to do with continuous growth. So continuous growth or decay, here's the formula. A of t equals A times e to the r times t. A is still the A in this case is the initial value. R is the continuous growth rate per unit time, and t is the elapsed time. If r is greater than 0, then the formula represents growth. If r is less than 0, then the formula represents decay. So for business applications, the continuous growth formula is called the continuous compounding formula and takes this form. A of t equals p times e to the rt, where p is our A, our initial value, the principal is. So let's look at an example. Alright, a person invests $100,000 at a nominal 12% interest per year, compounded continuously. What would be the value of the investment in 30 years? So A of t is equal to P e to the R t. So in this case, we're investing $100,000. E to the R, which is the interest rate, 0.12, times t would be 30. So if we type in 100,000 times E carried to the R, which they said was 0.12, times T, which is 30. Make sure that we had that right. T is 0.12, 30, and it looks like we get 3659823 points 44. So it looks like a person investing $100,000 at a nominal 12% interest rate per year compounded continuously will have $3,659,823.44 after 30 years. All right, so let's look at one where there is decay. Radon 222 decays at a continuous rate of 17.3 per day. How much will 100 milligrams of radon 222 decay to in 4 days? So here's the formula. Okay, so we want to know how much it's going to decay to. We're going to start with 100 milligrams. The rate that it's decaying is 17.3, which would be 0.173 as a decimal, but it's decaying, so it's going to be negative. We are doing this in 4 days. 4 days. So, just want to go back and show you that for the T is the elapsed time, and we're measuring time in days in this case. Okay, so let's just type this in the calculator. 100 e to the negative 0.173 times 4. And it looks like 50.05739 05739. I missed the 5. 05739. It didn't tell us how much to round to, so it is decaying, and it's taking it down to 50.05739 when it's decaying by 17.3% per day. Using the data in the example above, how much radon will remain after 1 year? So it's the same thing. A is still 100. E to the negative 0.173 times number of year. This is decaying per day, so that's 365 days in a year. So if I go to Desmos, I can just replace this 4 instead of retyping it with 365. Whew, and it looks like, you notice you get 3.77 e to the negative 26. What this is a scientific notation. So this is 3.77 times 10 to the negative 26, which means that basically you take this 3.77 and you move the decimal over 26 times to the left. So that's a number really close to 0. So there's always some remaining, so you can't ever get to 0, but it gets really super close to 0. So this is a very small number. Alright, and so that is all for this section. If you have questions, please let me know.